British atomic weapon trials in the years from 1952 until 1956, most of the devices tested have been fired from the top of aluminium towers. The tower enables the device to be tested at a predetermined height above the ground and under certain controlled conditions. Towers are extremely expensive to design and erect and can only be used for one explosion, and their height is limited. In October 1956, the Royal Air Force Balloon Unit at Cardington were instructed to provide facilities for a weapon to be hoisted on a balloon system. Number 217 Maintenance Unit at Cardington manufactured 1.5 million cubic feet of hydrogen for dispatch to Australia, and in August 1957, 74 of the personnel of the unit left for Operation Antler. From Cardington, Bedfordshire, to Australia, to Maralinga Village. Built by the Ministry of Supply during 1955 and 1956 to provide a permanent base for atomic weapon trials in the Australian desert, and first used in 1956 for the Buffalo series of test explosions. The flying site at Taranaki is 5 miles from the inflation site at Iwara. 50 tons of equipment, excluding gas, was taken to Iwara and unpacked. Balloons arrive in valise containers, together with their ancillary equipment and rigging.
Yes, we arrived at Maralinga and unpacked the gear. Then we got a balloon ready for inflation. Wind direction and speed determine how the envelope should be laid out. We call it flaking out, and we have to be very careful. First of all, ground sheets are spread out and everyone wears rubber shoes to prevent damage to the fabric. The balloon has to be flaked out evenly and pulled into position so that the center cable can be pulled through. You'll hear more about that later. This is the spider which holds the connecting cable between the balloons. It is positioned and connected to the ton patches on top of the balloon before passing the center cable through. Before inflation, a 14-inch gas valve must be fitted. A simple mechanical device which allows for the expansion of the gas under increases of temperature. It must be set correctly or the balloon will burst. An inner and outer ring, fastened with butterfly nuts, attach the valve to the balloon envelope. Final preparations for inflation take place. The lightning conductor is laced to the nose of the balloon. Each cylinder contains 500 cubic feet of hydrogen. All metal equipment must be earthed to specially driven points incorporated in the inflation beds. A tube from each cylinder goes into a 10-way filler which is connected to the inflation hose by means of 2 metal clips. The gas then enters a 3-way junction piece and goes from there to the balloon in a single-way canvas hose. During the inflation, tubes will be transferred from empty to full cylinders. Cotton sennets are used as tie-offs on the inflation sleeve of the balloon. Each cylinder is turned on separately, and a continual watch is kept for any blockage of the inflation sleeve. The fins and the rudder have to be pulled into the correct shape and position. The pressure of the hydrogen causes the gas hoses to whip, and they must be straightened to ensure a free passage of gas at all times. As the envelope rises, it moves about, and the lightning conductor must be steadied to prevent damage. The balloon has now enough lift to raise it off the ground, still, of course, with the inflation hose attached. The lift is taken to central anchorage, and the handling lines are held through a block. The balloon can now be transferred to the 2 winches used at this stage of the operation. It must then be pulled down so that the inflation hose can be removed. The rudder must be held away from the ladder as the hose is removed and the sleeve is tied off. The main balloon cable runs through the center of the balloon. This must be carefully examined for position in the cone of the center sleeve. On the 29th of August, a balloon was at its moorings and was struck broadside on by a dust devil. It was forced over so far that the nose hit the ground and it burst into flames. The fabric was still smouldering more than 1 hour later. These scenes show the central anchorage and pyramid legs with the position in which the balloon struck the ground. After this incident, the balloons were moored at a height of 300 feet to prevent this happening again. 1 week later, at 3 o'clock in the morning, a gale destroyed 3 balloons and in doing so turned this 10-ton winch over. Damage was superficial and was repaired in the transport workshops at Maralinga. Another winch was dragged backwards in gear right up to the central anchorage, a distance of 32 yards, and the 12-ton cable was broken close to the end fitting. An engineer from the Royal Aeronautical Establishment at Farnborough examines the remains of a fin from a balloon which was destroyed in this gale in order to identify the weak spot in the panels which caused the fin to tear from the main envelope. The result of such examinations will enable modifications to be made in future designs. From the inflation site, the balloons are carried by road to Taranaki, the flying site. One result of round 2 of the Antler series was the contamination of Taranaki, and despite the efforts of Health, Physics and Range Facilities Group, individual protective clothing was necessary for work at the flying site, and all personnel changed at health control before entering the contaminated area. At the flying site, the balloons are attached to mooring points. The end of the towing cable is taken from the winch and passed through a block so that it can be attached to the vehicle which pull it down and moor it. The 3 balloons are now ready for stacking. A transfer cable is attached to the crossover rigging. It is held by a specially designed clevis and pin which is bolted through and split pinned. Two balloons are stacked and are to be placed on top of the third one, which is moored at a height of 13 feet. The bottom one of the two will be moved over the third one. The final transfer leg of cable is coiled and will be attached to the crossover of the bottom balloon. The bottom balloon then goes up to a height of 180 feet before the handling lines come into operation. The handling lines, tubular bracing and apex assembly are now laid out. The 1250 feet telemetry cable is flaked out to prevent kinking. This scammel holds all 3 balloons by the handling lines, ready for the inertia weapon to be brought out from the weapon shed. It is brought out on a travelling gantry, and when sufficiently clear of the shed, it is disconnected so that the jib of the crane can hang directly over it. The crane carries the inertia weapon assembly over to the balloon system. The assembly is made up of the inertia weapon, firing and telemetry units, and it is transported very slowly, with 3 men steadying the load to prevent it swaying. The system is lifted so that the strop will carry the assembly as 20 feet from the ground.
When the load arrives, the telemetry connections are checked. It will be lifted to the correct height for transfer from the crane to the flying wires. The main flying cable is fastened inside the fairleads of the assembly. When the strop is attached, the system will take the full weight of the inertia weapon. In order to prevent any twisting movements in the load, the tubular bracing stays are fastened to a V-shaped yoke. The connection is made by a male and female joint with a pip pin passing through them. The telemetry aerial is fixed and equipment is checked at this height before the hoist. The load is let up a further 50 feet or thereabouts on the main transfer pennant and the two close-to-ground handling lines. When it reaches this height, the weight is taken over onto the main flying cable and the two upwind stays. The main transfer pennant and the two handling lines are disconnected and attached to running shackles on the main flying cable. The hoist commences. The telemetry control cable is laid out from the cable stand and is fed up to the weapon assembly. This was the first of the flying rehearsals, and at 500 feet, the center balloon burst. The system descended rapidly at first, but slowed down when the remaining balloons gained more lift at lower altitudes. A defective main release valve was the probable cause of the burst. Great difficulty was experienced in controlling the load, and the assembly bumped a few times on landing, but fortunately no damage was done to weapon functioning equipment. The rehearsal was abandoned. The balloon system was taken down and the load returned to the weapon shed. The damaged balloon was returned to the United Kingdom for examination. Well before dawn on firing day, the balloon unit moved their balloons the 6 miles from Iwara to Taranaki in readiness for this last test in the Antler series. Final checks were made on ground handling equipment and the 3 balloons were stacked well before Zedar. Telemetry towers are ready at forward control. Aerials aligned on Taranaki site. The inertia weapon is brought out suspended from the crane and is lined up under the system. This preliminary hoist enables control and telemetry circuits to be tested. The yoke is attached to the tubular braces. The inertia weapon assembly is now at its operational height of 1,000 feet. A specially designed shoe is passed through the snatch block and the stropping off attachment is fitted to it. The main flying cable is let up so that the lift is taken by the stropping off attachment, which is fixed to a strong point to withstand a pull of 25 tons. A telemetry device at ground zero monitors the flying cable. If the cable slackens, a visible signal is made at forward control. When the operational height is reached, the control and telemetry tests are carried out. The inertia weapon assembly is brought down by means of the main flying cable until it is 100 feet from the ground. It is then transferred from the flying cable and is pulled down by the main transfer pennant and the handling lines until it is 20 feet from the ground. A constant radio communication is maintained with winch and scammel operators. The telemetry aerial is removed and the yoke is disconnected from the tubular braces. The crane is brought into position and the assembly is transferred to it. The flying cable must be removed from the fairleads and the weapon strop is disconnected. With the telemetry cable still attached, the load is taken back to the weapon shed so that the inertia device can be replaced by the live weapon. Inside the weapon shed, the links between the inertia weapon and the remainder of the assembly are unbolted. Over 100 bolts have to be removed and replaced to effect this changeover, which takes about 45 minutes. The uncoupling is now complete. The inertial weapon is pushed away on the gantry. Only a few inches clearance is allowed between the weapon and the remainder of the assembly. Protective canvas screens are laced into place on the side of the weapon. These are for security and for weather protection. The test cables used with the inertial load are now removed from the firing unit. The live weapon is hoisted on the gantry by block and tackle to be placed on top of the firing and telemetry units, where it will be bolted into position. The completed assembly can now be taken out ready for the final hoist. The crane will carry it the 150 yards to the flying point. The aerial is fixed for the last time and the lead screwed on. There are two displays on the control desk, one by telemetry cable and one by the radio link. Telemetry checks are again made before the final hoist commences. The ripcord will deflate the balloons in the event of a breakaway. While the final hoist takes place, the site is cleared of all spare equipment. When the system is at flying height, all personnel except weapon functioning group will be evacuated. Inside the weapon shed, the supply cable is connected to the power unit. On instructions from firing control, the local safety key is turned from safe to live, and evacuation is completed. At 4:17 p.m. on October the 9th, round 3 of the Antler series was exploded.